Computer memories. Computer memories are categorized into 1. Internal memories, directly attached to mainboard, main memories, cache memory, registers. 2. External memories, secondary storage devices, disks, hard or floppy or optical disks, tape. The most important characteristics of computer memories are location, capacity, unit of transfer, access method, performance, physical type, physical characteristics, organization. The term location refers to whether the memory is internal or external to the computer. CPU registers, internal main memory and caches, external secondary storages. Capacity is the size of memory. For internal memory, capacity is expressed in terms of bytes or words with word size. Common word lengths are 8, 16, and 32 bits. Number of words. For external memory, capacity is expressed in terms of bytes. Performance. 3 performance parameters are used: access time, latency, memory cycle time, transfer rate. Unit of transfer. For internal memory, unit of data transfer is the number of bits read out of. The unit of transfer need not equal a word or an addressable unit. For external memory, unit of data transfer is the blocks. Addressable unit, smallest location which can be uniquely addressed. Access method is the way the processor can write or retrieve data to or from a memory. Sequential access. Access is made in a linear sequence. Direct access. Individual blocks have unique address based on its location. Random access. Each location in memory has individual unique address. Access time is independent on the location. Associative access. Data is located by a comparison with contents of a portion of the store. Access time is independent of location. Physical types. The most common physical types are semiconductor, memory, RAM, ROM, magnetic surface memory, used for disks and tape, optical, used for CD and DVD. Physical characteristics. The physical characteristics of data storage are volatile memory, non-volatile memory. Organization. The organization is meant the internal structure of memory cell. The physical arrangement of bits to form words. The physical arrangement of words to form a memory device. Memory hierarchy. Computer memory is organized into a hierarchy based on 3 key questions. How much? Capacity. How fast? Access time. How expensive? Cost or money. Memory hierarchy diagram and list. Registers. In CPU. Cache memory. L1 cache. L2 cache. Main memory, RAM and ROM. Magnetic disk, hard disk, optical disks, magnetic tape. Second lecture. 3 key questions trade-off. There is a trade-off among the 3 key characteristics of memory: cost, capacity, and access time. Faster access time, greater cost per bit; greater capacity, smaller cost per bit; greater capacity, slower access time. The bottom line: as one goes down the hierarchy, the following occur: decreasing cost per bit, increasing capacity, increasing access time, decreasing frequency of access of the memory by the processor. Locality of reference. During the course of the execution of a program, memory references tend to cluster, for example loops. Semiconductor memory. The main memory chips are constructed from semiconductor. Types of semiconductor memories: RAM and ROM. The main difference between a RAM and a ROM is RAM is volatile while ROM is non-volatile. RAM is written under normal operation. ROM is programmed outside the computer. Semiconductor memory cell. Basic element of a semiconductor memory is the memory cell. Properties. Exhibit 2 stable states, capable of being written into, capable of being read. Memory cell operation. The memory cell has 3 terminals capable of carrying an electrical signal. Select terminal, control terminal, data in, for writing, sense, for reading. Random access memory. RAM is used only as temporary data storage. Characteristics of RAM: random access, read/write, volatile, access time. Types of RAM: SRAM, Static RAM, DRAM, Dynamic RAM. Static RAM. A static RAM (SRAM) is a digital device, using the same logic elements used in the processor. Binary values are stored using traditional flip-flop. A binary bit is temporarily stored as a result of the operation of two inverters connected back-to-back. Dynamic RAM. That made with cells store data as charge on capacitors. A DRAM requires periodic charge refreshing to maintain data storage, even when powered. DRAM cell operation, address line active when bit read or written, transistor switch closed, current flows,